Okay. Welcome to this new session in this morning. We are discussing about VHDL programming. Okay, and in that we are discussing about basics of VHDL programming. Today we are going to start with the operators and that we discussed in the last lecture. And so now we are going to continue with the operands. Okay, so I'll share my screen. Screen is not visible. We were discussing about operands, and now what is mean by operands? It is the quantity which is defined by the operators, okay, which is going to decide about the expression which is used in the operation. Okay, so operator uses the operands to compute its volume. So operands that can themselves be expressions. Okay, so that means they can be constant variables or they may be expressions. So operands in an expression that include literals, then identifiers. It could be index name also, then slice name, attribute names, aggregates, qualified expression, then function calls and type conversion. Okay, so these are the different ways of expressing operands in an operation. So now we are going to discuss about literals. So now what is literal? Literal in the another words, we can say it as a constant, and they are classified into two types. One is the scalar type and another one that is array type. Okay. Now in scalar type, it could be character bit, then standard logic, or it may be boolean or real integer or type. And if it is a array type, then it is a string or bit vector or standard underscore logic underscore vector. Okay. So these are the different types of literals. Now, uh, another type of operand that is a identifier. Now, what is identifier? It is a simple name. Okay, that is given to that quantity that we want to define. So it is the name for, or we want to calculate. So it is the name for a constant. It may be a variable, a signal, then an entity, a port, a subprogram, and a parameter declaration. Okay, so it identifier could be anything from this. A name. Now, whenever we are declaring this identifier, we should remember that a name must begin with a alphabet letter. Okay, which way may be followed by letters, then underscore or digit. Okay, but remember that this underscore cannot be a last letter from your name. Okay, then again, this VHDL identifiers that are not case sensitive. So if you are writing XYZ, then it is which are in a small letter, then it is similar to small x and capital YZ, which is similar to capital XYZ, and which is similar to X, small y and Z. Okay. So that means remember that VHDL identifiers that are not case sensitive. Now there are some preserved words in a VHDL like entity, code, and type. These are the some reserved words in a VHDL. So that cannot be used as an identifier. So we need to remember that reserved words or the keywords that cannot be used as an identifier. And then as it is not a case sensitive, so we can write in any way this identifier. Okay. So now here you can see the example that I already told, that you can write identifier name as in any case. Okay. It will be similar. Then you can assign it as a S in the bracket, it is a 3. Now this is a array element. Okay, so that means S, and there are 3 elements in that array. Okay, then also you can give the name like x3. Okay, so it could be constant or variable. So in that way, also you can define a identifier. Okay. Then another type of operand, that is the index name. So index name, that is the name which identifies an array of objects. Okay. So the syntax for index name, that is the array name and then expression. Okay. That means now here where array name is the name of a constant or variable of the array type. Okay. And the expression that must return to a value within the array's index range, that is the condition when we are declaring this index name operand. Okay. So here now suppose we have one example. Okay. So that here there is a column which is having the range from 1 to 20. So we are declaring this type column is the range from 1 to 20. Then we are again declaring one row, that is a, or one object, that is row is a range 1 to 24. And then we are declaring an array which is matrix. It is an array of, in the bracket, row comma column. That means this is a two-dimensional array. Okay, which is of a Boolean. Okay, now you can see at the end of the statement there is a statement terminator, there is a semicolon, that is a given. Now we are assigning this data object, that is a signal S, which is as a matrix. Okay, so that means whenever we are saying S in the bracket 1 comma 1, then it will have the value at the first row and first column. Okay, if we are saying S in the bracket 3 comma 14, then it will take the value of third row and 14th column. Okay, so and all these operands or all these index names, that will be a Boolean type, because this matrix is of a Boolean type. So that means this will have the it will be also of a Boolean type. Okay, are you getting this? Hello?
Yes, ma'am.
Okay. Now, another type of operand, that is a slice name and alias. Okay, so slice name, that is nothing but a subset of the elements of one dimensional array. Okay, that means if we have specified some array, then slice names that are the subset of that array. Okay, but remember that this array should be one dimensional array. It is not possible to construct slice name for multi-dimensional array. Okay, so we are writing slice name for one dimensional array only. So this slice name identifies a sequence of elements of an array object. Okay, the direction must be consistent with the direction of identifier array type. Okay, so here direction should be consistent to the identifier array type. Okay, so here suppose we take one example, that is the we have the array, that is the A1, which is the bit underscore vector, which is 7 down to 0. Okay, then we write, or we have the another constant, that is A1 5 down to 2. That means A2 will take the value from 5 to 2. Okay, so this is the slice. Okay, that means we have taken part of the A1. Okay, now another type of operand, that is alias. Okay, so what this alias does, it creates a new name for all or part of the range of array object. Okay, that means if suppose we are saying alias A3, that is a bit vector from 0 to 3. Okay, so that means is A1 7 down to 3. Okay, so that means what we are defining, we are taking A3 as the new name for A1. Okay, which is the bit vector from 0 to 3. That means we are considering just a part. Okay, so here actually there are 8 elements in this, which are from 7 down to 0. Okay, now here we are taking it as a 0 to 3 is which part it is containing? It is containing part of A1 7 down to 4. Okay, that means A3 of 0, that will be equal to A1 of 7. Okay, then A3 1, that is equal to A1 6, A3 2, that is equal to A1 5, and A3 3, that is equal to A1 4. Okay, so here in this way we are giving the new name, or we are taking a new considering new array, which is a part of the array which we have defined earlier. Okay, then alias A4, that is bit. Okay, that means it is A1 of 3. So this A4, that will take value of A1 3. Okay, so whatever is the value of A1 of 3, that will be taken by A4. Okay, so this is the slice name. Okay, that means we are assigning in a alias, we are assigning a new name, while in a slice we are taking a part of that array object. Okay, now here we are another type of attribute. We have another type of attribute, that is a operand, that is attribute. Okay, now this attribute takes a variable or signal of a given type and returns a value. Okay, so that means whatever is the variable or signal that we have defined, so this attribute will take its value, take that value and return to that. Okay, so the following are commonly used predefined attributes. Okay, so whatever I am discussing now, that are the predefined attributes. So one is the left. Okay, now what is meant by left? Then when we are declaring this type of attribute, it will return the index of the leftmost element of the data type. Okay, if it is the right, then it will return to the index of the rightmost element of the data type. Then high, that means it will return to the index of the highest element of the data type. Low, that means it will return to the index of the lowest element of the data type. A range, it determines the index range. Then Reverse range, that means it determines the index of reverse range. Length, it returns the number of elements of a bit vector. And the event, that is represents whether there is a change in the signal value at the current simulation type. Now this is associated with signals because there we require what is the current simulation type. Okay, so that time we require this type of attribute. So here now whenever we are declaring attributes, that time we syntax for that is whatever is the variable that we are considering, then which will be followed by apostrophe or single quote and then attribute which we are going to consider. Okay, so if we take example of this, here initially we have declared a variable a1 which is bit underscore vector 10 down to 0. That means it will have the value 11 values 10 from 10 to 0. Now when we are saying a1 apostrophe left, that means it will return to the leftmost value and so it will return to 10. Okay, if we are saying a1 apostrophe right, that means it will return to 0. If we are saying a1 apostrophe high, then the highest value in this vector, that is 10, so it will return to 10. If we are saying a1 apostrophe low, then it will return to 0. Now if we are going to check the range, then a1 apostrophe range, then it will return to 10 down to 0. We can also reverse the range. So a1 apostrophe reverse range, that will return to 0 to 10 and a1 apostrophe length, that will return to 11 as there are 11 elements. So the length will be equal to 11. Okay, so this is how we are declaring attributes. Okay. Now the next type of operand, that is aggregate. Okay, now the aggregate, that is used to assign values of the object of array type or record type during the initial declaration or in an assignment statement. Okay, so whenever we want to assign the values of object or array type, that time we are using aggregate. Okay, so now suppose we have object, that is a type which is a color list. So this is a record type of data. So color list is in the bracket red, orange, blue and white. Okay, so there are the list in the color list that is given, that is a red, orange, blue and white. Okay, then another data type that is type color underscore array, which is array of color list of bit vector 1 down to 0. Okay, and then variable x, that is color array. So here now when we are saying about, or when we are calculating the values for the x, then it will have the values that is a 0 0 or 0 1, 1 0 and 1 1. Okay, so this will be the state for this x. Okay, now here also we can say that this red, that will be 0 0 or blue, that is a 0 1, orange, that is a 1 0 and 1 1. So here in the second line we define an array whose element number or the index range is given by color list. Okay, since color list includes 4 elements, color array type also includes 4 elements, all of which are a bit vector. Okay, instead of color list we can use range, that is from 0 to 3, and because this definition only defines the range, not the element type. Okay, so here we can have the value integers, that is from which is from 0 to 3 also, as here there is only range that is we have to define. Okay, so this is about the aggregate. Okay, then uh, qualified expression. Okay, so here uh, this qualified expression that states the type of the operand. Okay, now when these qualified expressions that are used, okay, so that is the question. So when the parameters in the two overloaded functions that are of different types, then qualified expressions are used. Okay, that means if suppose we have the same data, okay, in two different functions with different types, then we need to specify that in which type we are considering this. So that means to avoid the ambiguity, we need to have qualified expression. Okay. Um, so here, syntax for this qualified expression, that is a type name, single quote, and in the bracket there is a expression. Okay, so this is the syntax for a qualified expression. So here, let us have two variables. Okay, so the data type here, this is the record type of data. So type color one is in the bracket red, comma orange, comma blue, comma white. Okay, and another is the color two, that is the type color two is in the bracket purple, green, red, brown, and black. Okay, so now here this red that appears in both these data types. Okay, so whenever we are calling for any one of this data type, so we need to identify which is its data type. Okay, म्हणजे तो कुठल्या ह्याच्यातला आहे हे आपल्याला क्लिअरली कळायला पाहिजे. And for that we need to have qualified expression. So we write the statement like color to single quote or apostrophe and in the bracket red. That means now we are considering element red from color to data type. Okay, so is this clear to you? लक्षात आलंय काय केलं इथे? Yes, is this clear? Shall I continue?
Okay, ma'am.
Okay. Now suppose I am saying I want a brown. Okay, I want to define brown. Then how will you define? Okay, as it is in a color 2 only, but still we can have a qualified expression as a color 2 single quote brown. That means now here we need to consider a data type that is color 2. Okay. So now as we know that this VHDL, that is a strongly typed language. That means we need to clearly specify what is the type of the data. Okay. So sometimes we need to convert that data type into one another data type. Okay. And this type conversion provides this facility. Okay. But this is for only between the closely related types. Okay, so that means those types which are closely related with each other, in that only we can do the type conversion. Okay, now how to do this? A type name and in the bracket there is a expression. Okay, so here suppose we have one signal, that is the x, then signal x, which we have defined it as a standard underscore logic underscore vector, then range is 3 down to 0 semicolon. Okay. The another signal is that standard signal y, which is standard u logic underscore vector. That means it is a this standard logic that is a resolved vector, while this is a unresolved vector type. Okay. So now as these are both are the logic vectors, so these are the closely related data types. So we can convert this data type. That means we can assign y as a स्टँडर्ड यू लॉजिक वेक्टर ऑफ एक्स. ओके, म्हणजे जे काही आपण एक्स डिफाईन केला इकडे त्याला आपण कन्व्हर्ट करू शकतो कशामध्ये, U logic vector मध्ये. Actually, it was a standard logic vector, but now we can make it as a or convert it as a standard U logic vector. Okay, so here we can convert the type of that uh, object data type, but remember that this should be only between closely related types, otherwise it will show error, as this VHDL language is a strongly typed language. Okay, remember this word, strongly typed language, as it is very important. Okay, you need to define type of data very clearly and very correctly. Okay. Now, till now we discussed about operand and operator. But now let's move forward and then we are going to discuss about sequential statements. But as we discussed earlier, that VHDL provides uh, means to represent digital circuits at different levels of abstraction. Okay, such as behavioral modeling and structural modeling. So here we are going to discuss about different constructs for describing behavior of components and circuits in terms of sequential circuits. Now, so for that, when we are going for the sequential circuit, we need sequential statements. Now, this sequential statements that specify step-by-step behavior of the process. Okay. Now, actually, when we are going for the sequential modeling, the basis for that sequential modeling is the process construct. Okay, and this process statement is main construct in behavioral modeling. So that allows you to use sequential statements to describe behavior of system over the time. So here, when we are considering sequential statements, as I said, it will specify the step-by-step behavior of the process. They are executed starting from first statement and then second, then third until the last statement. The statement within a process are sequential statements, whereas the process itself is a concurrent statement. Okay, so here there are following types of statements that are used in a or that are defined in a VHDL language. Okay, so as we need to define a process, so in the process we need to define variable assignment statement, then signal assignment statement, then if statements, case statements, null statements, assertion statements, loop statements, next statements, exit statements, wait statements, then procedure calls, return statements. All these come in the sequential statements. Okay. So first of all, we will see how to assign or how to have variable assignment statements. Okay. So variable assignment statement that replaces the current value of variable with a new value which is specified by an expression. The variable and the result of the expression that must be of the same type. Again, I am telling that as this is a VHDL is a strongly typed language, so whatever we are defining or assigning variable and the result of that expression that must be of a same time. And this syntax that is used for this variable assignment, that is target underscore variable, that means it is the name, and which is colon equal to expression and then semicolon. Okay, so here this is the syntax for variable assignment statement. So when this variable is assigned, The assignment executes in zero simulation time. Okay, so there is no any delay when the statement that is executed. In another word, it changes the value of the variable immediately at the current simulation time. So variables can only be declared in a process or subprogram. Okay. So here, this variable declared within a process cannot pass values output outside of the process, and that is they are local to the process or subprogram. Okay. So remember that whenever we are assigning a variable, okay, so that time to any expression, so that expression, whenever that expression that executes, so variable value will change instantaneously. Okay. So there will not be any delay for the change in the value. Okay. But at the same time, we need to remember that these values cannot be passed through the different process. Okay, it will be only for that process. That means these variables are local to the process or subprogram in which we are declaring that variable. Okay, then let us take one example of this variable assignment statement. Okay, so suppose we have a data type that is a subtype, that means it is a part of the integer. That is why we are considering it as a subtype. Subtype, the given name is int16, is integer in the range from 0 to 65535. Okay. Then after that, we have assigned signal, that is a S1, S2. Both are of the type int16. That means they are also an integer. Okay. Then signal GT, which is of a Boolean type. Okay. Then we are starting with the process. Okay. So process S1, S2, which is here we are now declaring variable. That is A, B, which is of a int16. Then constant, that is also C, which is also int16, which has the value that is equal to 100. That means this is C is having the value 100, which is a constant value. Now, when we start begin, so begin A will be assigned the value which with the expression that is the S1 plus 1. Okay, and we will have the value that is S2 into 2 minus C. Okay, and then GT that will be assigned to the value that is here we are considering a logical operation A greater than B. Okay, so now suppose we will have one example. Suppose the S1 has the current value that is equal to 100. So what will be value of A? So after execution of this statement, what will be value of variable A? इथं आपण काय केलंय, ए आणि बी हे व्हेरिएबल म्हणून असाइन केलेत आणि जे काय आहेत int16 टाइपचे आहेत, म्हणजे काय असणार आहे, दॅट आर इन द रेंज फ्रॉम 0 to 65535. ओके, आणि सी हा काय डिफाईन केला, तर सी पण तो कॉन्स्टंट आहे आणि त्याची व्हॅल्यू काय आहे, 100 आहे. ओके, त्याच्यानंतर आपण स्टेटमेंट काय घेतलं, ए इज इक्वल टू S1 plus 1. Okay, now S1 has the value suppose 100. So what will be value of A after execution of this statement? It will be 101. Okay, B, suppose S2 is equal to 8. Okay, so now, okay, I'll take more value because otherwise this will become a signed number. So suppose it has the value 200. S2 has 200 value. So here we will calculate first S2 into 2. So it will be 400 minus C, that is 100. So it will have the value that is equal to 300. Okay. Now A has the value 101. B has the value that is 300. Now GT signal GT that we have assigned as a boolean. That means it will have only two values. Either it is a true or it is false. So as here expression for this GT, that is a greater than B. Okay, that means this statement will be true whenever A is greater than B, and this statement will be false if A is less than B. So now as A is 101, B is 300. That means this statement will be false. That means GT will have the value that is false. Okay. So this will be the execution of this example. Are you getting this?
Yes, ma'am.
Okay. So moving forward, now here in a process, we need to again define signal assignment. Okay, so there should be signal assignment statement. So now what does this signal assignment statement does? It replaces the current value of a signal with a new value specified by the expression. Okay, so in a variable also there is a change in the current value to the new value. But here in a signal assignment value statement also there is a change in the current value to the new value, which is specified by the expression. But there is a difference between signal and variable. Okay? The signal and the result of the expression that must be of the same type, and that is the condition for VHDL. That all the time, whenever we are expressing any signal statement, that time the expression that we are going to have that must be of the same type as that of the signal. Okay, and then syntax for this signal declaration, that is target signal, which is assigned to the transport, which after that expression, then after time expression. Okay, so when this signal is assigned, the assignment will not take that effect immediately, but instead it will be scheduled to a future simulation time. Now there are two types of delays that can be applied when scheduling signal assignment. One is the transport delay and another one that is the inertial delay. Now this transport delay, that is the delay because of the wiring condition, and this inertial delay, that is the delay because of the component or the circuit which is used in that system. Okay. Then next is the if statement. Okay. So here in a sequential modeling, we can have a if statement. So here if statement that selects for execution of one or more of the enclosed sequences or statements, which depending upon the value of one or more corresponding conditions, and the syntax is if, then the condition, then here after this then there will be sequential statement. Now if this is true, then there will be a, otherwise else if condition, another condition, then again there will be sequential statement, or it will be else, then sequential statement, and then end if. Okay, so this is the syntax. Now it is similar to that of how you are writing if statement in C language or C++. Okay, so there also we write this here if statement. So this, and continuing with this if statement, this is an expression specifying a condition that must be a Boolean type expression. Okay, so that means it will have only two values, either true or false. Okay, the condition of this if statement is first evaluated. If the condition is true, then the statement immediately following the keyword then is executed. Else, the conditions following the else if clauses are evaluated step by step. The final else is treated as a else if true, then. So, if none of the conditions before else clause are true, then else statement will be executed. Okay. So this is the how we have to define each statement in the sequential statement. Okay. So here there is a one example, that is a signal in one, in two, and OU. Okay. These are the standard logic signals. Then process ion 1 and ion 2, that is D will start, that is a begin. If ion 1 is 0 or ion 2 is 0, then OU will be assigned the value that is equal to 0. ओके. म्हणजे काय होणार आहे याच्यामध्ये, जर इन 1 ची आणि इन 2 ची या दोघांमधल्या कुणाची तरी व्हॅल्यू 0 असेल तर OU ची व्हॅल्यू काय असेल, 0 असेल. Else if it will go for the next, that means if ion 1 or ion 2 या दोन्ही मधलं कुठलंही 0 नसेल तर काय जाणार आहे, तो नेक्स्ट स्टेटमेंटला जाईल. Else if ion 1 that is having the value that is x or ion 2 that is x, then OU will have the value that is 1. Okay, so OU is assigned to 1. Else OU that is assigned to 1. And then end it, and then end of this process. Okay, now can anybody tell me how this will execute it? How the statements will get executed?
मॅम म्हणजे हे कसं वर्क होतं ते सांगायचंय ना.
हो.
हां मॅम, जर आपण दोन्ही इनपुट जर 0 दिले तर आपल्याला आउटपुट 0 मिळणार आहे. किंवा इफ एल्स म्हणजे आता एक इनपुट आपण 0 आणि एक इनपुट आपण 1 दिलं तरी आपल्याला आउटपुट 1 मिळणार आहे, म्हणजे x. आणि जर हे दोन्ही कंडिशन पण नसतील, म्हणजे दोन्ही पण 1 1 असतील तर आपल्याला आउटपुट 1 मिळणार आहे.
Okay. So if other than 0 कंडिशन असेल तर आपल्याला काय मिळणार आहे, आउटपुट हे 1 मिळणार आहे. ओके, सो दिस इज द if statement. Okay, then after that we are moving towards another type of statement, that is a case statement. Okay, so the case statement that selects for execution one of a number of alternative sequences of statements. The chosen alternative is defined by the value of expression. Okay. Do you know how to use case statements in C?
No ma'am.
Okay. Okay. So we will discuss it here. The syntax is for this case statement, that is case, then expression, and then is. Okay. Then when choices. Okay. So here there will be choice. Okay, that we need to define, and then equal to or less than. Then there will be sequential statement. That means the statements we need to execute. Okay. Otherwise, when choices. Okay. So we need to again have another choice. Then we need to define or we need to execute another set of sequential statement and then case statement. Okay. It is like when we have certain options. Okay, जर माझं असं झालं तर मी हे करणार आहे, आणि नाही झालं दुसरा ऑप्शन माझ्याकडे काय आहे तर त्याप्रमाणे मी एक्झिक्यूट करत जाणार आहे. ओके, सो दॅट इज डिफाइंड इन दिस केस स्टेटमेंट. ओके, सो each choice that must be of the same type as the expression. Each value that must be represented once and only once in the set of choices of the case statement. If no other choice is presented, all possible values of the expression that must be covered by the set of choice. ओके, सो प्रत्येक चॉईस हा आपल्याला काय करायचं आहे, एकदाच डिफाईन करता येईल. माझ्याकडे जर 3 चॉईसेस आहेत. ओके, सो I am going to select this one, okay, or another one, or next one. Okay, so that means like right now, okay, you have 2 choices. Okay, to attend a lecture sincerely, and get good marks. Okay, so that is the one choice, and another choice is that not to be too attentive and then getting the less marks. Okay, so आता त्याच्या पुढे जे काही होणार आहे त्याचे तुम्हाला सिक्वेन्शियल स्टेटमेंट मध्ये तुम्हाला ते येणार आहे. ओके, so that means here depending on the choice we need to execute this statement. Okay, so here example of this is, suppose we are going to define a signal which is an integer which is range, that is for this is the 0 to 7. Okay, then signal I1, I2, I3, these are the bit type. Okay, that means they will have values either 0 or 1, and then procedure considering these signals begin, the process will begin. So case S1 is when 0 or 2, then it will be output that will be equal to 0. When S1 is equal to 1, then output will be equal to I1. Okay, when it is in between 3 to 5, then output is equal to I2, and when other, output will be equal to I3. Okay, म्हणजे आपल्याकडे काय आहे, S1 च्या व्हॅल्यूज हा कुठून चेंज होणार आहे, फ्रॉम 0 to 7 या असणार आहे. ओके, तर जर S1 ची व्हॅल्यू 0 किंवा 2 असेल तर आपल्याला आउटपुटची व्हॅल्यू काय मिळणार आहे, 0. when it is equal to 1, then आउटपुटची व्हॅल्यू काय असेल, I1 असेल. when it is 3 to 5, that means 3, 4, 5 या केसमध्ये आपल्याला आउटपुटची व्हॅल्यू काय मिळणार आहे, I2 मिळेल. आणि उरलेल्या सगळ्या केससाठी म्हणजे 6 आणि 7, ओके, त्याच्यासाठी आउटपुटची व्हॅल्यू काय असणार आहे, I3 असेल. ओके, नाउ हियर देयर विल बी एंड ऑफ केस and then end of the process. Okay, so this is about the case statement. Okay, then after that we are going to discuss about null statement, but as we are having very few minutes, so we will stop here and we will discuss about these statements in the next lecture. Okay, so if you are having any doubts, tell me.